Hello everyone, welcome to the video lecture series of inverse Laplace and Laplace transforms. My name is Mayur Gohil. In this video lecture, I would be deriving a new formula in order to find Laplace inverses using integration effect of Laplace that we have already seen. So let us recall the statement. The statement said that if Laplace of f of t is equals to phi of s, then we have Laplace of integral 0 to t f of u du as 1 upon s phi of s. Okay, so now we consider this result that we found from the integration effect. Now if I take the Laplace operator onto the right hand side, it would become Laplace inverse operator. So I have taken it onto the other side. Okay, now we move to find an expression for f of u. So let us consider this statement that was given to us with the integration effect assumption, that is Laplace of f of t is equals to phi of s. Now Laplace of f of t being phi of s, that same thing, if you want to find expression for f of t, then that expression would be f of t is equals to L inverse of phi of s. If you concentrate on L inverse of phi of s, this same expression can be denoted as f of u. Okay, it doesn't matter whether the expression for the answer is in the terms of t or is it in terms of u, as far as the function remains the same. So it's just a mere notation. So this step is slightly important in order for us to understand. Now though we have got the answer f of t as well as f of u for L inverse of phi of s, for time being here f of u will be replaced by L inverse of phi of s. Now focus on L inverse of phi of s over here. That's what I am going to replace it here. So what I have is integral 0 to t L inverse of phi of s du is equals to L inverse of 1 upon s phi of s. Okay, now I have already got one expression. If you understand this step, L inverse of 1 upon s phi of s type of problem can be solved using this expression, that is integral 0 to t L inverse of phi of s du. We also had one general result along with the integration effect statement. That general result gets modified in the following form. If you are given a problem to find L inverse of 1 upon s to the power n phi of s, then you have such n integrals operating on L inverse of phi of s du, and that's what you are going to get over here, right? So now one very important thing here you have to understand is that your function operates in the terms of u till the last integral 0 to t that you obtain. Okay, it's very important here. Let us try to understand this entire procedure with the help of an example that we just saw. This general formula is what I will be using right now to explain you with the help of an example. Consider this problem, L inverse of 1 upon s square times s plus 1. Okay, now let us take up the formula that was L inverse of 1 upon s to the power n phi of s, and there are these such n integrals over here operated on L inverse of phi of s du. Now compare the question with the left hand side of the formula over here. So it is nothing but you have 1 upon s to the power n in the form of 1 upon s to the power 2, and your phi of s is nothing but 1 upon s plus 1. Okay, if you can recognize your phi of s easily, then you are through. You can start with the problem. So thus you have phi of s as 1 upon s plus 1. So now you find the Laplace inverse of phi of s, because that is what you need as per the formula. L inverse of phi of s is to be found. Okay, so we find the L inverse of phi of s. that is nothing but e to the power minus t. Now remember that in the previous, while deriving the formula, we said that f of t is going to act like f of u. So I'm going to write f of t as this. This is our f of t. It is nothing but e to the power minus t, and I'm going to convert it to e to the power minus u. It doesn't matter. T and u both play as a dummy variable here. Okay. Now, also the reason of replacing t by u is here. If you focus here, you are going to integrate with respect to u. That is one reason you need to write your function in terms of u. Okay. So, now let us see. This is the important step here. Okay. Now let us go ahead. If you try to write your problem in terms of the formula, you can write it in this manner. So because there is 1 upon s to the power 2, there is two integrals that are going to be operated onto the function e to the power minus u. Okay. Now you perform the first integration with respect to u. So integrating this e to the power minus u, you get e to the power minus u over minus 1, and the limits are 0 to t. Okay. Now when you substitute this 0 to t over here, you have to convert your answer again back to u, because there is one more integration that is left out, that is 0 to t. So that is just because of it's the dummy variable, you just every time replace your t by u. So what you have is integral 0 to t e to the power minus u minus 1 divided by minus 1 du. Okay, simplify this further, you obtain integral 0 to t 1 minus e to the power minus u du. Okay, now what you can do is, now when you integrate with respect to u, you integrate it and you get u minus e to the power minus u divided by minus 1, and the limits are from 0 to t. It is at this step, since you have reached your last integration process, like integral 0 to t, you have reached your last integral, right? It is that step you are allowed to replace u by t. Okay, so that time you replace u by t. Okay, and on substituting your limits, you get your final answer. So you have to understand here very important thing, that is, as many integrals are there, till the time you reach your last integration, integral 0 to t, it is only then you are supposed to replace your variable u by t. Otherwise you keep on using u as the variable, and only at the last step you use your variable t. Okay, so that's it on this, and so you are done. So you can practice these two problems for yourself, and if you have any difficulties, you can revert it to me back. It's very easy method, it's very straightforward because of this general formula helping us down the line. So there's nothing that difficult. Only thing is that you have to remember is you replace initially your function f of t by f of u, and it is only at the last integral, when you reach integral 0 to t, you are allowed to use the variable t. That's it, nothing more. So that's it for the day. Thank you.